Good morning, students. Welcome to EduWave online classes. Today we are going to start with work power energy for class 10 I.C.S.E. and this same chapter is covered in CBSE class 9. So without any further delay, let us start. What do we mean by work? Work is the mathematical product of force and displacement. Now we all know that force and displacement both are vector quantities. So we are taking the dot product of two vectors that results in a scalar quantity. So work is a scalar quantity. Now, when is work said to be done? Suppose we are applying force on a body in this direction and the body gets displaced in the direction of force. Then, in terms of physics, work is said to be done. That means there must be a force which has to be applied on a body, and due to the application of this force, the body must get displaced in the direction of the applied force. Then only work is said to be done. So, work done depends on two factors: force applied and the displacement. So these are the two factors on which work done depends. How much force we have applied on the body, and due to the application of the force, by what distance the body has been displaced in the direction of the force. These are the two factors which affects work done. Now we come to the SI unit of work done. Now, the SI unit of force is joule and the SI unit of force is Newton and the SI unit of displacement is meter. So, the SI unit of work done is Newton meter, but Newton meter is also the SI unit for moment of force. So we combine this and the SI unit for work done comes out as joule, abbreviated as capital J. So SI unit for work done is joule, which is abbreviated as capital J, and the CGS unit of work done comes out as erg. Now, what is the relation between CGS and SI unit of force? Let's see. It is 1 joule is equal to 10 to the power 7 erg. 1 joule is equal to 10 to the power 7 erg. Now, how does this come? Now, how does this 1 joule is equal to 10 to the power 7 erg comes? So, for knowing this, we need to know what is known as 1 joule of work. Now, if we apply 1 Newton force on a body, due to which the body gets displaced by 1 meter, we apply a force of 1 joule on a body and the body gets displaced by 1 meter in the direction of force, then work done is said to be 1 joule. That means we can write 1 joule is equal to 1 Newton into 1 meter, right? So 1 joule, now we know that 1 joule is equal to 10 to the power 5 dyne. 1 joule is equal to 10 to the power 5 dyne, and 1 meter is equal to 100 centimeter. That can be written as 10 to the power 2 centimeter. So if we combine these two, so we get 1 joule is equal to, the bases are same and they are in multiplicative form, so we have to add the powers. So 10 to the power 5 plus 2, that gives us 10 to the power 7 dyne centimeter. Now just like the way we have written Newton meter as joule, in the same way we are going to write dyne centimeter as erg. So that is how 1 joule is equal to 10 to the power 7 erg. This is how it comes. Okay. So I request all of you to go through this derivation. This is a very easy derivation, nothing to get confused, just follow the steps. Okay. So the students, those who have joined now, welcome to our EduWave online classes. We have our WhatsApp channel as well as we have our YouTube channel. The links for both these social media platforms will be given in the description box of this video. I request all of you to kindly subscribe our YouTube channel and follow us on our WhatsApp channel for our latest updates. We are also taking free online classes in Zoom platform. The links, the subjects, the topics and the teacher who will be conducting the classes will also be posted over there. So in order to stay tuned, please subscribe to our YouTube channel and follow us on WhatsApp. So let's again come back to the topic. Now, I have written the formula for work done as force dot displacement. Right? This can be further simplified like this. Work is equal to F(S) cos theta. Now what is theta? Theta is the angle between force and displacement. Theta is the angle between force and displacement. Now, suppose there is an inclined plane. There is an inclined plane. This is the ground. Now, the inclined plane makes an angle of theta with the ground or the horizontal. So, now if we place an object over here and we apply a force on the object parallel to the ground, this is the direction of applied force, then what happens to the body? Does the body go straight along the horizontal plane? No. It goes up the elevated slope. That means the displacement of the body is in this direction. The body gets displaced up the inclined plane, whereas we have applied the force horizontal or parallel to the ground, right? So here the angle between force and displacement is theta. This angle we are calling it as theta. So the simplified form for work done comes out as F(S) cos theta, right? Now there are several conditions for positive work done, negative work done and zero work done. Now let us first take the case of positive work done. Suppose we are applying force on a body in this direction and the body is getting displaced also in this direction. That means what? The angle between force and displacement is 0 degree. So case 1, theta is equal to 0 degree. That means we are applying force in this direction, the body is also getting displaced in this direction. So in this case, work done will be Fs cos 0 degree. Now we know that the value of cos 0 degree is how much? Plus 1. So work done will be equal to Fs. Here work done is positive. Here work done is positive, right? So if you are applying a force on a body in this direction and the body is getting displaced in this direction, then what happens? Work done is positive. Now, suppose, now we are moving on to case 2. Suppose a ball is rolling in this direction, that means the ball is getting displaced in this direction and we are wanting to stop the ball. So what we have to do? We have to apply a force in the opposite direction so that gradually the speed of the ball decreases and finally it stops, right? That means displacement is in this direction and we are applying the force in this direction. So their force and displacement are acting at an angle of 180 degrees. So in the second case, theta is equal to 180 degrees. So work done will be how much? Fs cos 180 degree. Now, just like the value of cos 0 is 1, similarly the value of cos 180 is negative 1, that is minus 1. So in this case, work done will be how much? Fs into minus 1, right? So if we multiply this negative sign over here, so we get work done as minus Fs. That means here work done is negative, right? Here work done is negative. So if force and displacement are in the same direction, then work done is positive. And if force and displacement are opposite to each other, then work done is negative. Okay? Now we move on to a special case when work done will be 0. Now what are the conditions when work done will be 0? Suppose we are applying a force on a wall or any other object that cannot be moved from its place, right? So whatever magnitude of force we apply, that is not going to move the body. So the displacement of the body is 0. So if there is no displacement of the body, that means displacement is 0, then work done will also be 0. This is the first one. Now, if the body is moving in a circular track, suppose the body has started from this point and finally after one complete rotation or one complete round, it has come back to the same point. That means there is no difference between the initial and the final point. In this case, displacement is 0. Again, if a body is moving in a circular track, since the initial and the final points are same, the displacement of the body is 0. And if displacement is 0, then again work done is 0. Next, suppose a man is carrying a load on his head and he is moving in this direction, right? So the displacement of the person is in this direction. Now we are taking gravitational force into consideration. So the gravitational force is acting downwards, right? So this is the gravitational force acting on the body. Now, in such a case, let us see what is the work done by gravitational force. Okay. So work done will be Fs cos theta. Now what is the angle between force and displacement over here? It is 90 degree. Right? Now we know that cos 90 is how much? 0. 0 multiplied with Fs gives us the overall value of work as 0. So even though both force and displacement exists in this case, but since the angle between force and displacement is 90 degree and cos 90 is 0, therefore the overall work done is 0. So these are the three cases, specific cases, when work done can be 0. Displacement is 0, we are pushing something. Even after pushing, even after applying force, the body is not getting displaced. That is number one. The body is moving in a circular track. Since its initial and final points are same, again displacement is 0. That results in 0 work done. And number 3, even when force and displacement exists, but since the angle between them is 90 degree, therefore work done is 0. Now suppose a body is falling freely under the force of gravity, right? So force, gravitational force acting on the body is how much? Its mass into acceleration due to gravity. And let's say the body was kept at a height h from the ground. So when it is coming and touching the ground, what is the total displacement of the body? It is the total height of the building or the tower or the pole on which the body is kept. So here S is equal to h, right? So according to the mathematical expression of work done, that is Fs. Because see, here we are not writing cos theta. Why? Actually cos theta is over here, but the force and displacement are in the same direction. So it is how much? Fs cos 0. We know that cos 0 is 1. So Fs into 1 gives us Fs. So now let us replace the value of F and S. So work done by gravitational force is equal to, in place of force we are putting mg, and in place of displacement we are putting h. And this is what we write as potential energy of a body. And from here we will connect it to the topic of energy in our next class. Work done by gravitational force when a body is freely falling under the force of gravity is mgh, mass into acceleration due to gravity into height from the ground. Okay? Now suppose we have been given one very simple numerical, a force of 10 Newton acts on a body, due to which the body gets displaced by a distance of 5 meters, and it has been mentioned in the problem that the angle between force and displacement is 60 degree. That is, theta is equal to 60 degree, right? So, like it is in the case of an inclined plane, we are applying force in this direction and the body is moving upwards. So now, we have been asked to calculate the work done. So we will be applying this formula, Fs cos theta. So work done will be F is 10, displacement is 5 into cos 60 degree, right? So that is 10 into 5, and we know the value of cos 60 is 1 by 2. So 2 5s are 10, that is 5 5s are 25 joule is the work done. This was a very simple numerical based on this formula that you have learned in today's class, right? So this is the most fundamental basic of this part, work. I again repeat that work is a scalar quantity whose formula is Fs cos theta. Now in our next class we will be solving some more numericals with this concept of work that I have taught you today, and we will be moving on to the next part of this chapter, that is power and energy. So again, I request all of you to kindly subscribe our YouTube channel and follow us on WhatsApp. The links for both these will be provided in the description box of this video. Till then, I wish you good luck. God bless all of you. Keep studying. Bye-bye.